So we're looking at intro to JavaScript today. And we're going to cover a couple things. We're going to talk about why JS matters and the internet, because JavaScript is the language of the internet. We're going to briefly talk about Node.js and what it is and why it matters. We're going to do a review of the JavaScript language features. We're going to get into variable types, primitive variable types, more complex variable types, and what the difference is. We're going to get into functions and a little bit about conditional logic. And in the second part of our lecture, we're going to get into a little bit with testing with this JavaScript framework called Jest and a little bit more advanced stuff. Let me get a quick show of hands, like how many folks have done a decent bit of coding in JavaScript already, whether it's for the pre-work for the course or just previously. So a decent number of folks, not everyone. That's totally fine. I will be writing some code today. If you want to code along, you can. However, this lecture is not necessarily paced for that. So if you are coding along and finding it a struggle to keep up, my recommendation is to take notes instead. And we will have assignment work time this morning, and you'll have plenty of time to be writing JavaScript code in the afternoon. So just very briefly, before diving into JavaScript itself, and as you all may have noted here, and can everyone read this Scratch file? Okay, by the way, does this work for me to throw notes in? Perfect. I have a multi-line JavaScript comment here. VS Code helps us out a ton once it knows it's a JavaScript file. You can do, you only need the slash and the 1 star. You don't even need this. This is still a multi-line comment. But I think the easiest thing is just do / and 2 stars, and it's sort of a convention, and then VS Code adds the closing one for you, and you can type stuff. A great VS Code keyboard shortcut to know is Control/ or Command/ on a Mac. It will comment or uncomment one or more lines. So, you know, this is a single line comment in JS. And with Command/ I can put that or put both of them. So that is super useful. And I'll leave those examples kind of lurking at the bottom as we as I fill this out. So features of every programming language. Every programming language has a syntax. Every programming language is going to have logical operators, if and else, and so on. It's going to have primitive data types such as strings or integers, numbers, and booleans. More complex data types, which under the hood are often built out of these primitive data types, like objects or dictionaries, which Python has. If the language is strongly typed or weakly typed, and if that phrase rings a bell to anyone, can anyone maybe describe what does strongly typed or weakly typed mean?
Strongly typed means that it forces, if once you declare a variable as like a string or an integer, you can't change the type. Weakly typed, you can flip-flop, it does its best to interpret what you're trying to use it as.
Yeah, exactly. And is JavaScript a weakly typed or strongly typed language?
It'd be weakly typed, right?
Exactly. And what about Python?
Also weakly
The
type?
same.
Exactly. You got it. And the rule here is, if I can do x equals 5, and then on the next line, I can do x equals hello, I've just changed the type of x from, well, in JavaScript, it's a number to a string. Right? Versus, say, y equals pi, y equals I. We change the value, but y is still a string. We'll talk about this a bit later, but the reason this matters is like at a low level in the computer memory, the computer will allocate, say, a different amount of space for an integer versus a string versus a list. And so way back when, like almost all the languages were strongly typed because you said, hey, an integer takes up this much space. Dynamic languages have, or weakly typed languages have more going on under the hood. There are some trade-offs involved, not worth going into right now. But so this is an important thing to know, right? This is sort of like programming languages 101. And then how do you run the code? Do you have to use one program to compile it and another to run the compiled source code? And when I say source code, what do I mean? Can someone maybe say, like, what is source code? Yeah, and this may be new territory. So this JavaScript file or any Python file that you write, whenever you're writing code that you're looking at as a human, that's called source code, as in like this is the source. And so with some languages, usually not weakly typed ones, but strongly typed languages like say C or Java, we might write our code and then we have to run a program called a compiler that turns the human readable source code into, it doesn't quite turn it into binary, but into something called assembly code that's quite close to it. That is not human readable at all. It's like zeros and ones and hexadecimal and stuff. And that's actually what the computer executes. The computer does not actually directly execute our source code. Like for my Scratch.js file, like when I add, if I go all the way down to the bottom, like somewhere in here, I'll just actually put right after here, we'll just put console log hello world. And as we all probably did during install fest, I'll use Node.js to run this JavaScript program on my computer outside the browser. What happens is Node.js looks at this JavaScript file and it's called sort of on the fly, or I think just in time compilation. It turns it into bytecode, basically, or assembly. It turns it into the stuff that the computer actually executes. The source code is really for us, for humans, for our readability. Does that make sense to folks? And do folks have any questions? Awesome. So both JavaScript and Python, their syntax has some differences, but some similarities. The syntax differences will be tricky. That's the trade-off for learning two languages. They both have the same kinds of logical operators, though the syntax is different, and JavaScript does a few things worse, as you'll see. They have mostly similar primitive data types. Almost every language has a Boolean. Every language has a string. Some languages might explicitly have an integer data type versus a float. So an integer would be 1, 2, 3, 4, 5. A float would be like 1.732, because at a low level, dealing with the number of decimal places can get trickier. JavaScript actually just has a number type, and I think Python does as well. There are differences, significant differences between JavaScript and Python with their more complex data types. JavaScript has arrays. Python has lists, though, which is similar but not quite the same. JavaScript has objects, which are really more like Python dictionaries, which we'll see later. So there are some more significant differences there. JavaScript and Python are both dynamic or weakly typed languages, and we don't need to use a compiler for either. We use, I call it like the Python runtime or the JavaScript runtime when we run this command node or Python on the command line. So that's sort of an overview, and your goal in this course, it should be really to go as deep as you can into both. And when you graduate, pick one to really focus on and master. Today, we're talking about JavaScript, though. And to talk a little bit about that, let me actually talk a bit about how the internet works, and that will kind of tie into why JavaScript is relevant. So when I go to wikipedia.org, I'll open up in my browser. We'll learn about this much later. It's called the Network tab. I'm going to see what my browser does. It sends something called an HTTP request to a server, which is a server is just a fancy word for another computer that receives a request and serves something back. You can have a server program running on your laptop and a client program running on your laptop. This idea of a server client architecture, where the front end is our client and the back end is our server, is a really simple architecture that gets used for all sorts of things. So pretty much all the apps on your phone are a client. A web browser is a client. A web server program like Django that we'll learn how to make later is a server. And again, you can write really simple client server programs, and a server program might be a client for something else. But my browser is a client, and it sends an HTTP request over to wikipedia.org. And we'll learn more about Wikipedia or HTTP requests later in the course. And wikipedia.org sends back a response. And this is happening over the internet, right? And the response is a bunch of text that just happens to be formatted in the hypertext markup language, HTML format. And the browser just so happens to know how to read that. And there's nice things like links, where now I'm sending the Wikipedia server another request, and it loads a different HTML page that then loads all this other stuff. And we'll go more into this later, but I just want to illustrate this basic idea of client and server and a little bit of what's happening when you use your browser online. And it doesn't matter if your browser is on your computer or on your phone or anything like that. And we refer to the client stuff as the front end and the server stuff as the back end. And it's two separate programs. And there's often a database on the back end as well. That's another program. We'll learn how to use Postgres as our database. We'll be learning to use Python and the Django backend web framework to write our web application backends, and JavaScript and the React front end sort of UI JavaScript framework to write our front ends for what's, and this is what we talk about when we say full stack, as in the tech stack is like, you'll see diagrams. Let's see if I can find a good one, in fact. Perfect. Let's see if it gets bigger. Yeah, so I apologize. We've got the fuzziness. This one is a bit better, but you can see it's just like that diagram, and that's where that term stack comes from. And the idea being like some things are maybe a little higher in the stack or lower in the stack, depending on like what happens first. And you can think of application architectures this way as well. But so we'll talk about a tech stack. And so the idea of like, there's the front end stack and the back end stack, and then there's full stack. And do folks have any questions? Cool. So what makes JavaScript special?
And it's never changed over like, I think it's been out for like almost 30 years now, and it's like never changed. They've only like added on to it. So like you can log into a website that hasn't been updated since like the late 90s or the early 2000s that have had any sort of like early uh JavaScript, or like, you know, even like the stuff in ES5 before ES6, like the updates only add to, so you can always like load that older stuff.
I would say yes and no. You're 100% right that what makes JavaScript special is it's stuck around. It became the language implemented in a web browser really early on, and it's still around. As you pointed out, there are different versions of JavaScript. We'll learn about like ES5, ES6 later. The language has changed really dramatically. And as you will get deeper into the course, unfortunately, you will learn that pretty much all code everywhere on the internet is a bit of a dumpster fire. And there's a lot of work that happens under the hood in writing programs when the JavaScript language changes. And there are certain language features like, say, let's see, we'll talk about what the arrow function is, which is one of the more modern JS language features. For a long time, it wasn't natively supported in browsers. Now it is, and there are all these workarounds that people had to do. So you have the right idea, but the language changes constantly, and keeping that working is a challenge, and it's not always guaranteed that your old JS code will work just fine, or any programming language, without some support. But you hit on the really important part, which is that JavaScript was really the first language where it could be run in the browser to do interactive stuff, and it still is really the only language that you can use in the browser to do interactive stuff, though there's something called WebAssembly that's a little outside scope. And I saw someone else had their hand up as well.
Well, no, I think you touched on it. It's just like it is the only language that I knew, other than the one that you just mentioned, that you can use to make your front ends interactable rather than static. So,
Yeah.
and you can also use it for the back end too, but I guess we'll be using Python.
Yeah, exactly. And you can use JavaScript to interact with and drive your browser. And we'll learn about that more in a couple weeks. So originally, JavaScript only ran in the browser. And then one day someone was like, hey, JavaScript is kind of a cool language. Let's take the JavaScript engine runtime named V8 that Google created for its Chrome browser and pull it out. And that's Node.js. And so like, we want to be able to run JavaScript on my computer outside the browser. But yeah, the reason JavaScript is special is anytime you see something interactive, like say this autocomplete pop-up that just happened, that's some JavaScript running on this website. And whenever you load a website, your browser makes all these HTTP requests to a server, not just to get HTML files, but also JavaScript files. And let's see if I can filter by file extension. And it's not really readable for humans. The JavaScript goes through a bunch of processing, not worth going into now. But so my browser requests a bunch of JavaScript from the server. And every time you see something like interactive, there's a decent bet it's the JavaScript. Like this is some JavaScript that our browser loaded running in the browser doing this. That's definitely some JavaScript. That's definitely some JavaScript. So that's really what JavaScript does. It lets us add all this interactivity and make more powerful websites and web apps that can do more stuff and talk to other servers. And so JavaScript is very much the language of the front end. And we teach both JavaScript and Python really for maximum flexibility. So I mentioned Node.js a little bit and what it is. And to show, I showed this yesterday briefly, but we've all probably used Node to run a JavaScript program. If you just type Node, this opens up what's called the read, evaluate, print loop, or REPL. The idea being, just like you would maybe write some code here in a JavaScript file and then run it, I write some code, but every time I hit enter, Node.js runs that code. I actually recommend, when I'm working, I'll have multiple terminal or shell sessions open, and I'll have one like that's just Node, because I forget stuff, maybe how to define a function, or if I want to test something out, it's really nice to have this open to be able to do stuff. And I can just exit it with Control-C. So let me, do folks have any questions? Okay, awesome. Let me start getting more into JavaScript variables. So there's a bunch of ways to create variables in JavaScript. I could do foo, and foo and bar come from foobar, F-U-B-A-R, and I don't know why, but it's sort of a programmer tradition to use these for like learning placeholder variable names. I could do foo equals hello. Another way I could define a variable is let bar equal goodbye. Another way I could define a variable is const, I don't know, z equals 13. Can anyone tell me what are some important differences between the three different ways here of creating variables in JavaScript?
So pretty much, if you use let, I think you're able to actually change the variable. And then if you use constant, it stays like that. You're not able to change it.
Yeah, totally. I can do bar equals sunny. And in fact, let's console log bar. And actually, we're reviewing JavaScript today, but what I'm about to say is actually probably the most important thing you can take away from today. Always run your code. I will run my code when I'm working almost after every line I write. Because what if, I make a mistake and I forget a parentheses and I don't notice it and I write like 30 more lines of code and I have 2 or 3 mistakes and I run my code and I have like 4 or 5 errors. That's really difficult to debug. But if I have that mistake and I've only like added 1 new line to my code and I run it, way easier to debug because I only added like 1 line of code. I'm pretty sure I know where to go to fix it. I'm only seeing 1 error message. So run your code constantly. You probably cannot be running your code enough as you're developing. So this works great, right? With let, I can change the variable value. I could do it here too if I wanted. We'll console log foo. Let's go ahead and do this for const as well. And let's say z equals 4 and console log. And note that I get really nice autocomplete hints. And in fact, I even get like definitions of language features that VS Code gives me. And I can even click on that link to get the full definition of this online from the Mozilla Developer Network web docs. And this site MDN has been around for a long time and is definitely the place to go to for JavaScript, HTML, and CSS. For web stuff, avoid W3 schools and go here. It's much better quality and better explanations, and W3 schools doesn't always have the info you need. And we can console log z. And note, like, if I hover over a variable, I get this really nice, useful information, and VS Code, like can sort of infer, because it has some smartness under the hood, it can make good guesses about what types of variables things are. And I can go ahead and run this and we're good to go. Except, uh-oh, I ran into a problem. And if I look at what happens, and I'm running down my code, so the runtime, Node.js, executes this file line by line, top to bottom, with a couple exceptions that we'll get into later. So when you're debugging, start at the top of your file and kind of in your mind simulate what the computer is doing and just move down. And here, because I have these print statements and it says hello world, I know I got this far and nothing here broke my code, which makes sense because it's just a comment. And my next print statement, my next console log is hi. And I know that's from line 40 here. So I know that everything in my code up to line 40 is good. Otherwise, because what happens is when Node.js is running my JavaScript code and an error happens, it stops running it and it's called throwing the error. It throws the error. And I'll talk about the error message in just a moment. And I see there was a question and I'll get to that in just a moment as well. So I know that through line 40, my code is good. And then the next print message is sunny, and I know that's coming from line 45, and I know all of that code is good. So just by the process of elimination, without even looking at the error message, I know that the error in my code is below line 45. And there's not a ton of code here, so I know it's something in here. And now let's look at the error message and let me talk about how to read an error message. If you run your code a lot when you're writing code, you will have less error messages when you make mistakes. If you have 10 error messages, like all in your console, it's harder to read, it's harder to debug. Sometimes error messages can be very long. The important information you need in an error message is almost always at the very top or the very bottom, and it will depend. With JavaScript right now, it's probably going to be at the top. And so whenever you look at an error message, start at the top or the bottom. If you don't see something useful, at the bottom, go to the top and vice versa. Here at the top, we have something useful. It's giving me a line number in my code. It's telling me the line of code that threw the error. And it says line 48. And below that, I get the error itself. And it says type error, assignment to constant variable. Now, all this other stuff is not useful in the error message. Though this 48:3 is a little helpful. This is line 48, third character. I usually don't care about the character, but it can help sometimes. And then everything below here is not useful. This is what's called the stack trace. It's printing out each line in like the internal code of Node.js where just giving us details on how stuff went wrong. We care about the parts of the error message that give us information about our source code that we wrote. Will, yes, sir. What's up?
Yeah, so above when you express foo, so on line 38,
Mhm.
is it best practice to put const or let before assigning it?
Yes, it
Or
absolutely
changes
is.
to that? Okay.
100%. I'm going to get there in just a minute. But
Okay, gotcha.
yeah, but since you brought it up, actually, let me touch on that super quickly. What Will is saying is hey, yes, we can create variables like this. You can also do it like this if we wanted to. Let and const are newer JavaScript language features that came out around 2015. Always use let or const. I recommend start with const, then change to let if you need to. Because though it sounds a little counterintuitive, changing the values of variables actually starts to get very tricky. It's called mutation, right? Changing. And that's actually where a lot of tricky errors can slip in. So if you start with const, and what const does as we saw here, is when you define a variable with const, JavaScript doesn't let you change it. It doesn't want you to do that. So in this case, if I really needed to change the value of z, I would have to change this to let. And now if I run this code, it works fine. And let me go ahead and copy this and paste this here, and I'll just change this to const, and I think I'll comment this out and say example of const not letting us change the value of a var. Sometime, so you can, if it's easier, you can start with let. It's not the end of the world either way, but don't define variables like this without let or const. Don't define variables like this with var. Both of those are old ways, and you should always just use let or const when defining a variable. Does that make sense? And do folks have any questions? Awesome. Let's talk about JavaScript functions. So I think all of you have some familiarity with functions. Let's say I want to create a function in JavaScript named makeFullName, and I want to pass my function to arguments. You'll hear people say function arguments or params, and these are inputs. And the more you start thinking about your code as stuff that takes input, that takes data as input, does something to it, and spits out some output, the easier it is to reason about your code. And the more you think about your data, the easier it is to reason about your code. The data is actually more important than the logic. So for makeFullName, I want it to be a function that takes first and last name and returns them together. So it needs to take two arguments, first name and last name. And the way that I'm writing this code, where the first letter is lowercase and there's no spaces or dashes between words, but then the letter of the next word is uppercase, is called camel case. And that is how you should write your JavaScript. And you can use tools like ESLint or Prettier that I'll show maybe a bit later to help remind you to do that. And we will be giving you feedback if you don't, because code is for other people. It's actually more important that other programmers can read and understand your code than almost anything else. So I'm creating a function. What the function does, the body of the function lives inside these curly brackets. And this function is going to return first name plus, and this is called string concatenation, which is just concatenation is a fancy word for combining. And in JavaScript, we can concatenate or combine strings with the plus sign. You probably do want to still put semicolons at the end of like each line of code in JavaScript. You don't need to do it after defining like function body stuff. This is the semicolon is a little vestigial, but still important sometimes. And let's go ahead and run this. And let's do my name equals makeFullName Adam. And actually, I probably should console log my name, right? So I can see if my code is working or not. And let's run this again. So my name is Adam undefined, right? There's a couple interesting things happening here. First off, why does it work that I can call this function before I define it in JavaScript? This may be a new thing, but does anyone know what's going on there?
Isn't it called hoisting?
Yeah, exactly. This is kind of unique to JavaScript. It's honestly a little weird. In most languages, this would have thrown an error. Like if I try to do console log some variable, and then I do const some variable equals, this will not work, and I run my code, I get an error, right? The error is on line 61. Reference error cannot access some variable before initialization. And initialization is a fancy word for creation, because JavaScript is running through my code line by line. It gets to line 61. It says, cool, I'm going to print something. What am I going to print? A variable name, some variable. Let me find it. And it looks through all the code that it's looked at line by line. And it says, hey, this variable doesn't exist. And it throws an error. So what I have to do is define the variable first. What JavaScript does that is a little weird is we can call a function before it's defined because of function hoisting. What JavaScript does do is sort of Node.js and JavaScript will do a first pass and find all the function definitions, and you can imagine it cutting this and pasting it at the top of the file and hoisting it to the top. It's not really a huge deal whether you define functions lower or higher. I think it's personal preference, but that's just a bit of a weird JavaScript behavior that's good to point out. So what about the more interesting thing here of Atom undefined? Why did my code print out undefined? What did that mean? How can I fix it?
You didn't pass the second argument.
Exactly. And Saul, I see you had your hand up as well. Oh, sorry. Did you have your hand up and then dive in at the same time?
No, it was the same thing. I was just gonna say there was just a second argument that you didn't pass. He got it.
Totally. So that makes perfect sense, right? We defined a function. It's got two arguments, first name and last name. When I call the function, I need to pass it values for those arguments, strings or variables or whatever, and I only passed one. Now, some languages would throw an error if you define a function that takes two arguments, but you only pass one. The number of arguments that a function takes is part of what's called its signature. JavaScript, unfortunately, I think does not, because the problem here is my code didn't break. It worked, but it was wrong. I actually want my code to break sooner rather than later. And can someone explain, what about undefined? What the heck is that and where did it come from? And this may be a good thing to touch on and a bit of a newer thing. So let me talk a little bit about.
Sorry.
No, go ahead, please.
Is it just because you tried to, because you're running the function, right? So, and you had the first name, but you don't have the last name in there?
You have the right idea. And let me
So it's like
dig.
you only have one parameter?
Exactly. And let's dig a little bit more into what that means. Let me go ahead and create a variable. I'll just do const. This has no value. And I'll do let also no value. And let's console log. This has no value. And let's console log also has no value. Before I run this code, interesting, we'll see if that red squiggly throws an error. Const declarations must be initialized, so it won't let me do that. So in fact, I should get an error. Okay, I actually did not know that. That is, I would say, a nice thing about JavaScript. We'll just name this has no value, like this. So anyone want to predict what line 78 is going to print when I run this code?
Undefined.
Yeah, undefined. I can create a variable. I can give it a name, but I haven't given it a value. Undefined is a special type of value that a variable can have. And I saw a hand up there.
Yeah, I just had a quick question about undefined. If
Yep.
it throws undefined, will it stop the rest of the code from continuing, or will it just move on? It's not an error, because it's not an error, correct?
Great question. Based on our console log statements, when I ran my program, what do you think?
Yeah, it would just continue on.
Exactly. The execution, really good question. And that is honestly one of the sucky things about JavaScript. The execution of this program, when we talk about the flow of execution, does not stop. This is not actually an error. This is obviously a bug. This is something that we don't want, but this is perfectly valid JavaScript that executes just fine. And this is part of the reason why people kind of hate JavaScript, and why when you can, using const is kind of a good idea, because what const does is JavaScript for const will say, hey, I'm not going to let you do that. You do have to define it. And honestly, that's better, because that lets you know for sure you have a problem. This is easy to miss. This is easy to miss. And there's all sorts of strategies, like coding strategies, that you'll learn about that people have developed for JavaScript to deal with this. There's a whole nother language called TypeScript that is built on top of JavaScript to deal with JavaScript. Programmers dislike JavaScript so much that they wrote another language that compiles into JavaScript. Because JavaScript is the only thing that runs in all the browsers. JavaScript has some awesome language features, and it has some things that are basically a huge pain in the ass. But so undefined is a special type of value. And what's happening here with this function is we have created these variable names when this function gets executed. When JavaScript executes this code, say from line 60 on, creates this variable, it prints it, goes to line 65, says, oh, I'm calling a function. I already hoisted the function, so let me go find it. Here's the function definition. Let's jump here, and the exit flow of execution is over here. And it passes in this argument Adam. And it says, hey, I need to create two variables, first name and last name. The first one will have the value Adam. The second one, well, I've created it, just like we saw over here with the let on line 79, but it has no value. So I'm going to give it the value undefined. Now what should I do? I need to return something. What do I return? I return this stuff. I could have done, full name. I could have written my code like this, right? Where JavaScript says, what do I do? Well, I create a variable that combines these strings, and then I return that variable. Since we don't need this variable anywhere else in this function, it's a little cleaner to just write it like that. And so that's where the undefined comes from. And the challenge here is there's no way to tell that this is wrong. And what we'll learn later on this morning is how writing tests will solve this for us. Because one really good practice is something called test-driven development, where, say, when I write a function, or even before I write my function, I write a test that's going to execute this. And I'm going to make sure that when I pass in first name and last name, I get what I expect. Now, I don't know if it would catch this case, but that is a little more outside scope. So I'll just put in K in there for my last name and go ahead and run this, and we're good to go. So let me just pause and see if folks have any questions. And is this a useful review for those of you who have done some JavaScript? And for those of you for whom JavaScript is newer, do you feel like you're starting to get a sense of the important features of the language? Okay, awesome. For those of you for whom this is a bit more of a review, what I would say is Google JSDoc, JSDoc. It's a standard for how to write comments and how to comment functions. Note that VS Code set this up for me. This is all a comment, even though these colors are different. That's VS Code just helping me out. And I did it with the multi-line comment with the slash star star. And here it wants param, right? This at param is the function parameter or argument. And it wants the type. And this is all a comment. This is not code. But now if I hover over this, VS Code gives me information about this function based on that specially formatted comment. And if I call this later, like make full name 7 who, well, it doesn't actually throw it. TypeScript will actually throw an error, but it can be this can be helpful because VS Code will give you hints. So for those of you a bit more familiar with JavaScript, look up JS doc and start building the habit of always writing proper JS doc comments for your functions. And the idea is you just say, you know, combine first and last name to return the full name. And also something to think about is I could have done a console log statement, right? I could have done that. What's an advantage of not doing a console log statement and doing return here instead?
A console log is, oh, sorry, someone else raised their hand.
Oh, yeah, Nika, go for it. And then Michael, I'd love to hear your thoughts as well.
It's okay. Maybe because, like you said earlier, we want to look at functions as bringing input or data in and spitting out an output, and a return would do that. But I think console log doesn't.
Yeah, exactly. Exactly. If instead of a return statement here, I do console log first name plus plus last name. Yeah, what is my function returning now? Nothing, as you pointed out, Nika. And I think it will actually return undefined. I think that's the default JavaScript behavior. The mathematical definition of a function is something that when you give it the exact same inputs, it gives you the exact same output every time. And if you start to think about your code that way, it will make your life easier. As Francisco mentioned the other day, there's also this concept in programming called the single responsibility principle. It's a little subtle, but this function is actually doing two things. It is creating the full name and printing it to the screen. Those are two things. This function does one thing. It also makes this function way easier to write a test for, which we'll learn about later. But maybe I don't always want to print out the full name. You know, maybe I want to use it with some other thing. Maybe I want to be able to say something like, you know, console log, my name plus lives in Chicago. And that's happening because I forgot a return statement here. So I didn't do that on purpose, but this is a great little debugging moment. And also add tons of console logs or in Python print statements when you write code. They let you see the flow of execution. They're your best friend because from looking at this, I see these undefined. I know something's wrong right away. I know I should be getting stuff printed out so I can look at my function and I can say like, oh, I'm actually not returning anything. Really, I should have gone to red squiggly there, but that's okay. So the single responsibility principle gives you flexibility because I can do way more different things with this function than if it console logged out. And Michael, I think you might have had a thought as well. So I just want to check in.
Basically just what you guys said, return actually returns the data that you're requesting from the function call, and log just logs it to the console when you're doing what you're doing right now at the bottom of the screen.
Yeah,
So-
exactly. Awesome. Awesome. Cool. We have a bit more ground to cover. We actually hit most of the complex stuff I wanted to get into this morning. I apologize. I might run 10 minutes past the hour, but then we'll break and we'll have work time until 11 Central. So for the next hour, where you can do a couple JS programming exercises, and then we'll look a bit at testing. So if it's okay with folks, I just want to keep rolling on to wrap it up to talk a bit more about like variables and data types. Does it sound good to folks? Awesome. Let's do it. So we've hit functions pretty hard, and we've managed to cover a lot of things along the way, and also talked about the single responsibility principle. Excuse me, I lost my train of thought there for a moment. And so now we start talking about variables and data types. And in fact, we've just learned about like one data type, undefined. And when we talk about primitive variables, we're talking about these fundamental building blocks or primitive data types, right? Undefined is a primitive data type. It's like built into the core of JavaScript. There's also a data type called null. If I believe I have that right. This has a value. So null is a special primitive data type to indicate that something has no value for a reason. So it's subtly different than undefined. And if I run this code, it prints out null. And it can be useful because sometimes I might need to create a variable before I know what value to give it. So there are sometimes very good reasons for something to be null. Sometimes there might be good reasons for something to be undefined, but null lets us like have some control. And it can be useful for things like, maybe const my user's age equals null before I've created a user account. Like in places where we might use 0, if the real value is not 0, we can use null instead. So null is another primitive data type. Strings are another primitive data type that's very core to the language. We can use double quotes to define strings. When I use double quotes, I can stick a single quote inside. Obviously, with single quotes, that would cause a problem, but I could use what's called, I believe, like the / for an escape character. It's either / or \. Let's see if I got it right. And in fact, let me go ahead and run this. And what I'm going to do is I'll just do a string plus that, because I just want to get it all in one print statement just for simplicity. Let's see if I got my escape character wrong with the single quotes. Yeah, so right, if I'm defining a string with single quotes, uses the /. Probably you can just use double quotes most of the time is what I would recommend. What's really useful is something called string interpolation. That's a bit of a newer language feature. Let's say, let me give an example. So string interpolation, you use the backtick, which is the little thing that looks almost like a single quote left to the one key. And then what you can do is inside that backticked stuff, inside the string interpolation, and this is like a Python F string, which we'll talk about tomorrow and some of you may have seen already. You can interpolate or put inside of the string another string variable that gets printed out. You can actually do some nifty stuff with this. I think you can actually put like some conditional logic in here if you really want.
You forgot
Hey,
the
Adam, you need
$sign.
the dollar
Dollar
sign.
sign.
Oh my God, thank you so much. That would do it. And you need a dollar sign. And lo and behold, VS Code was trying to tell me that the whole time. And I'm curious what this name is deprecated. So this is a sort of JS helper program I have telling me basically don't use variables with the word name because there's some JavaScript specialness to that word. So I'll just change this to name1. Actually, let me do this the better way of right-clicking and going to rename symbol and changing it to name1. Oh, and that didn't even work because there's the JavaScript specialness. There we go. And now we've got Alice and Bob. And this can get even fancier. For instance, $, make full name. You can put logic inside these interpolations because this is like an escape valve from a string to the rest of the JavaScript language. So fingers crossed I got that right and that this will run. As always, your guide for like how crazy to go with this stuff should be readability and simplicity. What you can also do with strings is under the hood, strings use the JavaScript array data type, which I'll talk about in just a bit. So if I did something like another name equals Benjamin, I can actually access each character in that name the same way I would access the different elements in an array. And I apologize, let's make that be the right variable and see if that works. There we go. So let me just pause and see if folks have any questions around strings. Brett, yes.
Yeah, I just had a quick question. On line 97, is there a reason that you would use a single apostrophe for that string and then do the slash apostrophe instead of using quotation marks to contain the entire string?
No, that was just for demonstration purposes.
Okay. Would it work if you used an apostrophe and then, or quotation marks to contain the string and then an apostrophe inside, or are they interchangeable?
You mean like here on line 96?
Oh yeah, yeah, okay. Cool, thanks.
Yeah, no, good question. I'm glad you asked it, and that's what this review is for. Nika, yes, what's up?
It's a quick question, and maybe it's just something that you do, or maybe it's best practice, but when you were choosing the variable on line 102, you put name and you spelled out 2. Why didn't you just do name with the actual numeral 2?
Yeah. Oh, sorry, go ahead.
I mean, because you can do that with the variable name. You can,
Yeah.
right. Why did you spell out 2? Maybe it doesn't make much sense, but I just wanted to know.
That's a great question. I don't know if it's a best practice. I will say it's not a bad idea. You're totally right. In JS, you can create variables like name one, name two. Might be easier, to be honest. For me, this is a little more readable. Also, like just from jumping between programming languages, like from JavaScript to Python, or say like with Postgres, like when you create a database in Postgres, I don't think the name of the database can start with a number. So that was just sort of like my naturally conservative instincts kicking in, because honestly, you know, I've been doing this a long time, but unless I'm like writing JavaScript all day, every day, so many things get out of my head and I forget. So sometimes it's just easier for me to do the thing I have like 110% confidence in. So yeah, that's a great question. Not necessarily a best practice, just more of a habit. Yeah, really good question. Thank you. All right, let's talk a bit about another data type in JavaScript, which is numbers. So JS just has the number type that is both integers or floats. It doesn't have anything else. There's a great built-in JavaScript function called typeof. So if I do console.log type of 5, this should print number. If I do console.log type of 3.14159, the first couple digits of pi, I think that should print number. If I do like x equals 32 and we do x, I think that should also print number. Let's see if I got that right. And that works. Yeah. So there's some value to typeof. It's not that discriminating because it basically will tell you it's a number. It's a string. Let's see if JavaScript does this or not. Yeah, so there are certain cases where JavaScript tries to get smart and would turn this into a number. Thankfully, it doesn't do that there. JavaScript has some built-in math features that we can use with the built-in math. It's sort of a JavaScript object. For instance, if I want to square 3, raise 3 to the second power, I do .pow, short for power. Or if I want to round down to the floor, what's called the floor of a decimal or float type number, I can do it with math.floor. And let's go ahead and just console log that as well. And as you all are noting, we can absolutely nest stuff inside of parentheses, and it can be a very nice shorthand. It's like I don't need to create like an extra variable here. There's no really one right way. I think it's more whatever is more readable for you. And so here, 3 is squared, raised to the second power, gives us 9. Here, 5 is lowered to the floor. 5.23 is lowered to the floor, which is 5. And there is a bunch of other, math features, but those are the main things. Booleans are a classic, and every programming language has a Boolean. Boolean comes from this term Boolean logic, invented by this guy, Charles Boole. And this is, the logic that you all are familiar with true and false and so on. And in JavaScript, these two vertical lines mean or. So let me throw a couple things in here, in fact. And I think these are all possible combinations. Let's see. We'll put that one here. So this is saying, right, what JavaScript does is evaluate this Boolean, this conditional logic, and then it will print out the Boolean value that this returns. This is actually, you can think of it like a little function. So what do you all think is gonna get printed out here for line 131? True or false? Not a trick question.
True.
Yeah, totally. How about line 132?
True.
Yep. Why true? I see true or false. So why does JavaScript print out true here?
Because it has a true. If it sees that true, it'll make it true.
Because it is true or false.
The
What about
expression evaluates to true.
what about line 133? True or false?
True.
False.
I think it evaluates the true, right?
It'll
Because
come first.
it'll go until like with the or operator, doesn't it go until it finds a truthy value in that expression,
Yes.
and then it'll evaluate it based on that.
I think it only
Yeah.
goes to the first one.
Yeah, so
That's the first one.
great thoughts. The last one I think we can all agree is false. There were some thoughtful answers that were not correct, and there were a couple correct explanations in there. The great thing about programming is we get to be scientists, and every time we run our code, we run an experiment. I forget how details of how JavaScript works all the time, and my gut test is always just running the code, which, by the way, this is where having like a REPL open all the time is great, because if I'm not, that is so fast and easy to do when I'm writing code. Let's run this real quick, see what we get, and talk about why. So we got true, 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 and false. And so the reason that line 133 is true, which is also the reason that line 132 is true, is that the way that an or statement works in JavaScript and in most programming languages is something called short circuiting. And what short circuiting says basically is like Boolean logic sort of prefers true. So like if I have an or statement where true or false are both acceptable, if I hit true up front in my or, I say, hey, I'm done, I'm true, we're finished, I don't even need to evaluate the second part of it. Here, first we hit false, but the Boolean logic says this can be false or true. So let's look at the other one. And it says, hey, this actually does not evaluate to false because the second one is true. So because of this behavior called short circuiting, line 132 will return true and line 133 will return false. Does that make sense? I feel like I might have gotten a little lost in the weeds on that explanation, so I want to check in with folks to make sure that we feel good about this.
Maybe I misheard you, but did you just say 133 would go to false, but you put true, and from what you said, it's true? Or maybe I misheard you.
Oh, 133 goes to true. I might have misspoke.
Okay, I'm just double checking.
Totally. No, and in fact, this is what I have the REPL open for, because I forget this stuff all the time. Yeah. Jorge, yes, sir.
Does this only apply to the console.log, or does this also apply to the like other functions like if and the other
This has
ones?
nothing to do with console.log. This is all about the way that Boolean logic works in JavaScript. You raise a great point. I could do, let's say, const zzz equals true or false. Think of this as a little function with two arguments, true or false, and it's using JavaScript's own like how to do Boolean logic function. And that is going to print out true as well when I run this code. Because when you look at this console log, if it helps, you can think about adding extra parentheses inside. When JavaScript runs line 131 or all these lines, what it's doing is it says, I print something. What do I print? It looks inside here and it says, oh, this is not a variable. I have to evaluate this first to figure out its value. Let me use my built-in Boolean conditional logic, operators to evaluate this to figure out what it is, return that, and then print it out. So when this code executes, it gets to these, and each of these is evaluated to whatever it is before we hit the console log. And you kind of see that same thing happening here, right? So the console log itself isn't relevant. Does that make sense?
Yes.
Awesome. Yeah. And the more you do it, the more comfortable you'll get with it. Will, yes, sir.
Is it best practice to put the first, like the first Boolean thing that you're going to evaluate as like the default or the catch-all?
I
That
think
makes
it
sense.
will totally depend on what you're trying to do and what the logic itself of the problem should be.
Okay.
Yeah, because there's no best practice because it really depends what you're doing. People absolutely do take advantage of this short circuiting behavior all the time. I think what you're asking is, if I have an or statement, how should I write it? It's going to depend on what you want that or statement to do and what the meaning of that or statement is within the bigger logic of your program. But there definitely will be times where, hey, I'm writing an or statement and I do care about the truthy value, so I'll stick the true up front. So we hit it first, then short circuit. Tyler, yes, sir.
Adam, would you say, like, I guess in my experience, like it usually the or statements are either going to be only your edge cases or they're not going to be your edge cases at all. Like at least in most of the.
As you write bigger programs, you'll be using or statements for all sorts of things.
Okay.
Yeah, I totally get where you're coming from. They're used for all sorts of stuff. I do want to wrap up, folks, and hit a couple more points so we can take a break. So I apologize, but please just throw your questions in the chat. One annoying feature of JavaScript that I want to point out is something called truthiness. JavaScript tries to get smart and it considers certain kinds of values to be truthy. Positive integer values are truthy. It returns 1. It doesn't go to false. This is like true. If I change this to 0, it prints false because JavaScript will treat 0 as falsy. It treats null as falsy, and it also treats undefined as falsy. Programmers will use truthiness all the time. In some ways, it's unavoidable. It treats any sort of string as truthy, but it treats an empty string as falsy. And note that for the truthy ones, it returns the actual value. This can be useful. It is also a common source of hard to discover errors. My recommendation is, as much as you just be very careful when using truthiness and just thoughtful about it. I want to talk a little bit about, well, I apologize. We are running a bit long. So I think what I'll do is, I do want to make sure that we have enough time to write code. And I did get a little in the weeds on certain things. Let me touch on arrays and objects, and then I think we'll break and work, because those are probably the most important bits. The other things kind of in the first part of our lecture with conditional logic and loops, I think you all are more familiar with. And I'll come back to those things after we get some work time to demo that. So let me just quickly talk about arrays and objects, and then we'll break and tackle some problems. So we can use arrays in JavaScript to hold an ordered list of values. And we can put whatever kind of stuff we want to put in there. The order of what's called an element in an array is called its index. Arrays in JavaScript and Python too are usually indexed starting with 0. So this is first, or sometimes you'll hear people say like the 0th element in the array. It can be a little confusing. I'll say 0th element, but sometimes I might just say like the first thing in the array, and I mean the 0th element. So the main takeaway here is when you're indexing or grabbing things in arrays, the counter, it starts at 0. And for instance, if I print this out, we can see we've got Monday, Tuesday, Wednesday. JavaScript under the hood uses a data type called objects that I'll talk about in just a moment. And you can add all sorts of different behaviors onto objects. And I'll show how in just a moment. When you create an array under the hood, it's also a JavaScript object, like most other stuff in JavaScript. And a very common function or behavior for any sort of array is something called push, which adds something to the end of the array. And in fact, I can console log the whole array if I want to. And console log will figure it out. So push has added something to that end of the array. And let me now talk about objects. And these are probably the most interesting and one of the more powerful things in JavaScript. So objects are what we call key value pairs. Let me, I'm just sort of naming things with names that I know won't conflict with other stuff. An object is just 2 curly brackets. You give it a key, like say, my key. The key can have a value, like say 7. And you can, there's a bunch of different ways to access different keys on an object. You can separate keys, value pairs on an object with a comma. And so here we've got the whole object printed out. And here's just a bunch of different ways of accessing the same key on the object. Objects can nest. You can use different values inside of objects. You can put other objects as values on an object key. You can put arrays as values. So you can start to do interesting stuff like this. An object key can be a number if I wanted. Maybe this is some ID. So I'm nesting objects inside objects here. As you can see, the enter doesn't really matter. This is a really common syntax or style of writing objects in JavaScript, and I do recommend it. I could have an array of, whatever I want. Maybe there's another object inside that array. I could have something be null. So objects are incredibly powerful and flexible. In fact, I can also have an object key be a function. So I could actually do database get full name so I can add all sorts of interesting stuff on my objects. Now objects are a little more limited. Like if I wanted to like have this get full name, like look at the other properties on the object, that gets trickier. So it's a little more useful to think of objects as like collections of data and like some functionality, and just try not to go to town with them too much. And you can reassign object values. I could do database dot something, dot push, yet another thing. I could do database 457 dot name equals Jerry to change Tom's name to Jerry. You can use this dot notation to access the keys as you go deeper into your nested object. So that's probably a good stopping point. There's one or two other little things, but they're less essential, and I can get into them later. Let me do a quick preview of the assignment that we have to work on right now. And then we can break and take a bit of a break, and you can at least get a little coding time in. And then we'll return around 11. And I do apologize that I've been running a bit long. I'll try to keep us a little tighter so that there's more work time tomorrow. Well, let me go ahead and show this assignment and kind of show how to get started with it too. So this is linked to from our curriculum repo. And I would get started with this. And the task here is we want to take a function that takes a number and returns its factorial. It's always a good idea when you're looking at an assignment to just poke around at the code. Spec is short for specification, and it's often used as a shorthand for tests. We're going to learn about like testing, writing proper tests with a helper library a bit later, but we sort of did some simple tests with console logs. We'll learn about require later. But what require does is let us import code from another file. So what's happening in this factorial spec file is we import factorial.js. And if we take a look at that, we see there's a function here. And so your task is to fill out this function with the logic to make it real and actually do a factorial. Do not change the name of the function. Make sure it returns something. Your function can only have one argument. You can change this name if you want, it won't matter, but I don't think you should. There's no reason. And do not change this line of code at the bottom because that's how you export it. And as your programs get more complex, you'll learn that names are really important. And there are certain things you can't touch without breaking other things, because our test file that we wrote, and I'll show you how to run it in just a moment, depends on, it expects there to be a file in the same directory named factorial.js, and then it will run that method. So let me show you real quick, just the flow of, I'll copy this repo, like I was doing the assignment, and how to run the tests, and then we can break and you all can get a little work time in. Sound good? Awesome. So I'm going to move through this a bit quickly, but if you want to code along, you can. So I'm going to go ahead and copy this repo and then like connect it to my own that I'm going to create, like you're going to do for this assignment and all the other assignments. And let me open up the iTerm terminal just because that's a little easier for me to do that with. And I'll just go into projects. So I go into, and I'll put this over here, and I'll put this over here. So I've gone ahead and I've hit the link to clone this repo for whichever authentication approach I'm using. I'm in my projects directory where I want to put all my stuff. I'm going to do git clone and clone the repo. I apologize, I already have it there because I was experimenting with this earlier. So I'm going to git clone to clone the repo. I'm going to navigate into it. I'm going to type pwd and git status to make sure I am where I think I am. I'm going to type git remote -v just to remind myself. So now that I've cloned this repo from our Code Platoon assignment GitHub work, I want to create a new repo on my own GitHub to put this in so I can have a copy. So I'm going to create a new repo on my own org, and I'm going to name it algo3 just because I've been doing this a bunch of times. But you should probably just name this the same as the assignment. But you can name it whatever you want. You can make it public or private. Don't add a README. Don't add anything else. And just create the repository. And Brian, you did a great job demoing this yesterday again. Make sure I've got the right URL based on if I'm using HTTPS or SSH. And now I want to do git remote set URL origin and paste in the link to my GitHub repo. And now, fingers crossed, I got that right. It looks right. And I should be able to do git push. And if I got this right, I can refresh the page. And now I've got my challenge. So now what I'll do is I'll open this current directory that I'm in VS Code. So now I've got my VS Code set up in the right spot. I'm where I want to be. I don't need this welcome. And I'm just going to open up both of these files. This is where you're going to write your code. These are the tests. Just for fun, let's do node factorial JS. It doesn't do anything. As you're writing this, you absolutely should add console logs to help you with the task. What I can also do is run this test file or spec file. And I can do node factorial spec JS. And false means the test doesn't pass. And since I haven't written any code, it shouldn't pass. And so we built this out to help you sort of develop iteratively or in a sort of test-driven development style. And as you're writing out your function, work on getting each test to pass one by one. And you should be running this test file a lot, as well as running factorial JS a lot. Don't touch or modify the test file. Do folks have any questions about how to run the tests for this assignment? Okay,
No.
awesome. Let me go ahead and stop the recording. So we're going to look at more advanced JS language features that are now an accepted part of the language, but a lot of these came with the version of JavaScript called like ES 2015, that around 2015. And the important thing with this stuff is to start becoming familiar with it. Again, we'll be switching to Python, but we're going to be coming back to this, and all of these things will be relevant when you're writing front-end code and using JavaScript to use React.js and writing JavaScript code with React. A lot of these features are what's called syntactic sugar, which is basically an easier way to type something. And you'll sort of see what I mean as we go into it, like where maybe the core functionality already existed, but this lets us as programmers do it a little more elegantly and easily. And we're also going to have an intro to testing and testing with Jest so that we can start taking advantage of that power. let me bump up the font size just a bit here. So let me go ahead and talk about arrow functions. So there's another way to write a function in JavaScript, and it's called an arrow function. And actually, before diving into this, there is a JavaScript language feature about functions in general that's really important. Functions are first class in JavaScript. This is sometimes called a language having first class functions. And something being first class means that you can assign it to a variable. And you actually saw me do this, but just to show this real quick, I can create a function named say hello. I could create a variable named hi and assign my function to it. And if I run this code, what did it not like? Hello is not defined on line 16. Can anyone see what mistake I made here on line 16 that is throwing this error?
Quotation marks.
Yeah,
Hello's not a variable.
not intentional, but someone's got a hot mic. Please just kind of keep an eye on if you've got the mic on and are talking into it and stuff like that. Yeah, we got to add some quotes. And more interestingly, you all saw me do this with the object earlier. So I can pass functions as variables. Really interestingly, I can pass functions as arguments to other functions. I'll just change this actually. Let's just call this message function. And if I call hello world like this, check out what we get. Hello and world. So I can start to do some nifty things. Maybe we want to add someone's name. Maybe we want this to be a template string. Maybe I want this to have the name as well. Maybe we wanted to say this. Sorry, I lost my file. In fact, maybe we wanted to look like this. And if I got this right, let's see, what did we get wrong here? I'm missing a semicolon. So this told me the line of code that has the error. The red squiggly pointed me in the right spot, and hovering over it, VS Code actually told me exactly what the problem was. I forgot to add a semicolon to close out my console log. So we just did some really cool composition there, passing a function as an argument to another function. So that's a first class function. And the reason that this is interesting is because arrow functions are sort of a shorthand to this. They do a little bit more, but they make this process easier. And an arrow function looks like this. I don't need to say function. I just need the opening and closing parentheses. I've got my inputs on the left side of the arrow and my logic with the output on the right side. And if my arrow function is only one line of code, I don't even need a return statement. So this is a great example of syntactic sugar. So there's a bit more to arrow functions than that. But once you get comfortable with this, it's very readable, it's very clean, it's less code to type, it makes life easier. And I didn't make this mistake on purpose, but what did I do wrong here? Why aren't I seeing the full name of whoever's name I want to print out on line 34?
The paren.
Yeah, I forgot to pass arguments to my function. It's printing out that, hey, you passed me a function, but you didn't actually call or execute that function. The parentheses call the function. And just like we saw earlier, I can call my function, but if I don't pass arguments, JavaScript will put in undefined. You can also make multi-line arrow functions. Just with the curly bracket. So if I wanted to, I could say, you know, let's actually do this. I'll just grab that inside the console as well. So there's a lot of nesting. It's good to start getting comfortable with it. So here I've got a multi-line arrow function. For the single line arrow function, you don't need arrow brackets or a return statement needed. So we've seen passing functions as arguments, and that's a feature of a language that has first-class functions. A function that takes another function as an argument is called a higher order function. And JavaScript arrays have a built-in behavior called map that will do something to each thing in the array. And it is expecting another function to be passed to it. So this is a really core feature of JavaScript. So if, say, I have an array of numbers that I want to double, I can do nums.map, and I can pass it an arrow function. And map will pass in each element in the array as an argument to my arrow function. And then I can do something with that. So this is more advanced. If this feels a bit new and confusing, that's okay right now. When we come back to JavaScript more a couple weeks, you'll be doing more of this. The main thing here is to see some functions expect to take other functions as arguments. And this is not unique to JavaScript, though you see it used a lot in JavaScript because of the way JavaScript works. And inside here, I'm defining a tiny little one-line arrow function. And we'll learn more about map later. Another useful modern JavaScript syntax feature is something called destructuring. Because so much of your code will be dealing with data and shapes of data, nested objects and lists and arrays. Excuse me. So let's say we've got just a simple array of stuff. So I know that, I could do, I can access the first thing in the array this way, the second thing in the array this way, and the third thing in the array this way. But if I have to do this for a bunch of stuff, this can be a bit of a pain to type out. So something I could do instead is and we can just put my array, or I'll put X. Actually, let me rename this A and B and C so they don't conflict. I apologize. And let's print these out just so we can see this in action. So this and this do the same thing. This is a newer JavaScript language feature that's syntactic sugar for destructuring an array to take the stuff in it and assign it to variables. And this newer way with destructuring, you don't always have to use it. It's not critical, but you will see it pop up and it's good to know. You can also destructure objects. If I have an object with a bunch of keys, say like that. Well, as you all know, I can do, I'm just going to do const a equals my object a. I'm just making up variable names that are simple and I know won't conflict with anything else. I don't like using let to reassign stuff. It can cause confusion. And I can print this stuff out, right? Console log AA and BB and CC and so on. And by the way, if like my typing speed is too fast or too slow, let me know. Sometimes I'm not always tracking that. We can do this with object destructuring though, in less lines of code and more succinctly. So instead, what I can do is, you know, create some variables and assign each key from my object to them. And let me actually just, let's do shorter names here. And in fact, let me just demonstrate this with, there's a couple different ways to do this. Let me show both ways, actually. So here's the first way. Where I can grab the keys from an object. This is the better way to do object destructuring, though. Where I've got an object and I want to grab those keys out of it. In fact, maybe I even only want 2 of those keys. Cannot redeclare blocks. Oh, do I have this defined somewhere else? Yeah, let's do just XX, YY, and up here, let me do XX and YY and ZZ, so those names don't conflict with other things. And now we should be good to go. And so what I've done here is a shorthand for saying, hey, JavaScript, I've got an object. I know it's got these keys. Grab those keys, create a variable with the same name of that key, and give it that value. So now this way I don't have to do, you know, like const XX equals something dot XX, or every time I want to use this, do something dot XX. And especially once we get into React.js, this pattern will become more and more useful. So let me show you guys just a little bit with one more kind of nice language feature. Something called the spread operator and importing and exporting. And then let's get to testing, which is really, I think, the good stuff. So let's say I have an array of stuff. Maybe I want to make a copy of that array. There's a couple ways to do this in JavaScript. But now with something called the spread operator, there's a much easier way to do this. So I'm not even going to worry about showing you guys the old way. And the spread operator is these 3 dots. And what it does is it tells JavaScript, hey, take this other thing, this array or this object, and copy it inside of this thing, but we're not nesting arrays, right? Like if I had done this is not a copy, first of all. And second of all, we end up with an array inside of another array. So that looks a little different than I expected. But what we can do here is we make a copy of the whole thing. And it lets us also add stuff. So I can copy this array into another one, add more stuff up to it, and still keep my original array intact. I can also do this with objects. And what I've got here is I tell JavaScript, take this object, break it up, give me all the key value pairs, use them to build this other new object, and add this other key value pair onto it. And do it without deleting or modifying the original object, right? Because I have my new object that has the stuff from the other one, and I still have the old one. And this can be really useful, and especially when we get into React.js later, this becomes really important because there are certain reasons why you want to make copies of stuff instead of modifying things. So the last thing I want to demonstrate is importing and exporting, and then we'll take a short break and then we'll look at testing. We're going to learn some other ways of importing and exporting later. This is sort of the more basic way, but there's no setup required. So let's say that we have a function named really important message. And what it does is, it returns this is important, and it returns the message. And because this message is really important, I need to use it in other places. Let me go ahead and create another file. Let me go ahead and split this. Let me go ahead and use Command P to open the new file that I just made. And there's nothing in there right now. So importing and exporting code between files depends on two things in JavaScript. You have to tell the file you've got the stuff in that this is something you want other files to be able to grab, other modules, and then you have to go ahead and import it. Under the hood, when JavaScript looks at files, it turns them into what's called modules, which is just this sort of catch-all term for stuff around namespacing and how code is organized. And so we sort of get for free this special object called module that has this other special property on it called exports. And I'm just going to demonstrate the basics of this for now. And there's two patterns to doing exporting. If I just need to export one thing, I can do it like this. And then when I want to import it, I can just do really important message. And since this is in a different file, there's no namespace conflict. I use this special keyword function require that is saying, hey, Node.js, look in the same directory I'm in. This is a relative path for this other file. And then Node.js will say, cool, I'm going to look at this other file that's a JavaScript module. I'm going to see if it's got like a module.exports, and whatever is in there, I'm going to send that back to you. Let's see how we do. Let's see if we got this working. And there we've got our important message. If I need to import more than one thing, and let's make up another function. There's a slightly different pattern we follow where module.exports becomes an object. And I need to give my object a key and a value. And we're going to be able to export and then import this whole object and all of its key value pairs. And so here, I'm adding functions as values on this key value pairs, and I can then import that object with those functions. Now, JavaScript has some nice syntactic sugar. When you're making an object and you're using a variable to assign as a value, if you also want the key or this key value pair to be the same thing, you can just do this. And that's way more concise. Now, if I wanted this to be something else, if I wanted the key name to be different from this variable name, I do have to do it this way. But so often you use variables in this way that this is super useful syntactic sugar. So then importing becomes slightly different. And here's where we can use object destructuring to help make our lives easier. We still need to require, oh, not request animation frame. Sorry, I don't know why it is doing that. And we're still requiring from the same file, and I've got the relative path to it. And if I did it this way, I would have to do, let me just name this object. In fact, I would have to do something like this. Object dot, really important message. Object dot, another message, and so on. And sometimes that is what you want to do. But a lot of the times, you just want to use the stuff on the object, and your object is just, it's like your shipping container. We care about the stuff inside the shipping container. So I can use object destructuring to make this code a little easier and more readable. Okay, awesome. I know I covered a lot of ground. I do want to hold on questions, though please throw them in the chat because I want to make sure we have enough time to look at tests. Let's take a short break. Let's just take 2 minutes, and I'm going to throw the timer on so we can stretch and get away from the screen and refresh ourselves. And then we're going to dive into testing. Sound good? Awesome. Thank you, everyone, and see you all in 2. Hey, folks. All right. We are going to talk about testing, which is going to be awesome. Writing tests, you always end up using like a testing library. Each language has a whole bunch of different testing libraries. A really popular one in JavaScript is called Jest. And it's always worth checking these things out on NPM and on their GitHub. Like maybe take 5 minutes and read a little bit of this. It's always the getting started, install stuff, and the install and save. And we're going to be using NPM, the node package manager, which you all have been introduced to, but we really haven't covered yet. And let me go ahead and close out some of these other files just to free up a little space. So, you all learned a little bit about Python virtual environments yesterday. JavaScript has the same problem as Python of I want to install modules or libraries that other people wrote. In JS world, we call them packages, node packages. How do I do that? How do I manage the different versions of stuff? And how do I keep things organized between projects? And that's what this command line tool NPM is for. And it works a bit differently than Python and virtual environments. So in JavaScript, when I'm starting a new project where I know I'm going to need to install stuff, I run this command in the directory I want to do this in, npm init. And let me go ahead and make a directory, and let's just call it testing example. I'll go inside there. This code might vary a little bit from what we have in the repo for today's lesson in the curriculum in terms of names, but the content should be the same. And when I'm inside the directory I want to create a new project in, I hit npm init. It gives me all these defaults. I'm just going to hit enter for all of my defaults right now and not worry about anything else. So what this has done now is created a file named package.json. And we'll learn more about it later. But the main thing is this is like the configuration file for our JavaScript Node.js project. And we can edit it and change it and stuff. And let's kind of watch what happens to this file as we do things. So I can also use the node package manager npm to install other JavaScript libraries or packages. With npm install and the save flag will add the name and version of package I want to use to package.json so I can check this into version control. And let's see what this does. And Jest is our testing library that we're using. 3 things have happened. A directory named node modules was created with a whole bunch of stuff because Jest has its own dependencies that needed to get installed. A file named packagelock.json was created. And this has all of the other packages we installed and way more information about them. And if we look at the package.lock.json file we already had, Jest was added as a dependency. And .json stands for JavaScript Object Notation. We'll learn a bit more about it later. It comes from the syntax of JavaScript objects and looks and functions not quite the same, but very, very similarly. You need to use the double quotes around stuff for keys, but otherwise this is almost the same as the JavaScript object format. But this is just text at the end of the day. So we've installed Jest. I'm also going to create a file named .gitignore. And inside this file, I'm going to put the name of every file or directory that I do not want Git to check into version control. All of these dependencies that we installed, they're out there on a server on the internet. I don't want them in version control on GitHub. I want the package JSON on the package lock with the version. Then when you clone my project, you can just run npm install. It'll grab the newest, latest, greatest versions of these things and install them on your computer. And this way we don't have to have all this stuff in version control. And we'll go deeper into all of those things later. The thing that's important for us for testing is in package JSON under scripts, we're going to change test to a command that we want it to run. And the command is just Jest. And that is actually going to run this JavaScript program that we installed. And we can use npm to run this from the command line. So let's go ahead and write some code and write some tests for it. And this is giving a bit of a preview of the solution to the problem that you were all working on with the factorial problem. So I'm not going to go too much into the implementation right now, but remember, I'm not going to worry about the num param now, but a factorial is, 5 factorial is 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And so that's what our function is going to do. I know I had to skip over a bit kind of using for loops. I think this is probably the easiest bit to pick up because the loops are so fundamental. I'm happy to go over this with folks that want to review this during the afternoon. And this for loop is going to count down. And we're going to multiply a number by itself and keep decrementing this, this counter. And then we're going to return this product from multiplying all these things. And now I am going to export this. And since I know this is the only function that's ever going to live in here that I care about, I am just going to do it the first way with the simple exports. Now let's write our tests.
Adam, did you mean to do let I equals num?
I absolutely did. Thank you so much. On line 9, that should not be null. Thank you so much. Good eye. Actually, I should take my own advice. Let's do a quick informal test and a sanity check of factorial of 3, because 3 times 2 times 1 is 6. 4 times 3 is 12. Times 2 is 24. So that should be an easy one. Let's make sure that my factorial function works before we start writing tests for it. And indeed, I forgot a return statement on line 13 because I see an undefined here. So the moral of the story here is to programmer error is human. We all make mistakes, use lots of console logs and running your code all the time so that your mistakes are little and easy to fix. The goal is not to not make mistakes. The goal is to make lots of little mistakes that are easy to fix and not big, messy mistakes that are hard to fix. So now I think we're cooking. I'll just leave that there commented out. Let's write a test file. And in JavaScript, we need to name our test files in a certain way. Our file extension needs to be .spec.js so that when we use the Jest testing library tool, and I need to do touch factorial.spec.js, Jest looks for files that say .spec.js in them. And I'm going to go ahead and split this. And I'm going to go ahead and open up my spec file. And I want to make sure that this is the right one in the right directory because we have this in our example code as well. and testing example, you have the file paths up here, which can be kind of useful. So I should be in the right spot. So if I'm going to write a test of this function, what's the very first thing I want to do? Can I even run this right now? Like if I do factorial 4.
Got to import.
Yeah, exactly. This doesn't even exist right now. If I do node factorial.spec.js, factorial is not defined. We got to import. So first, I got to import the function I want to test. And again, remember, this is a relative path, and this is where this is why programmers get obsessive about consistency, because the bigger your program gets, the more the different parts of it need to know how things are named and where they live. So with Jest, when we run Jest will automatically import some stuff for tests. So we get a couple things for free when we write code. And one is this function named test, which I apologize, the VS Code autocomplete wants to go in another direction. And this test function takes 2 arguments. The first is a string describing what the test is. The second test is an arrow function. We're passing another function to this test function that it's going to run and do some stuff with. And this is a multi-line arrow function, so it's got the curly brackets. Another function that Jest gives us for free is a function called expect. And we pass expect, in this case, 1 argument. We're going to call our factorial function, passing it 4 as an argument. This is going to do some work. It's going to return this object that we can then call another function on. This is a pattern called method chaining that you'll see in JavaScript as stuff gets more advanced. So for the moment, don't worry too much about how this works. Focus on the syntax and the readability. We use expect. The argument we pass it is the thing that we are testing, the value. Like if I had done, I could do this, const result equals factorial 4. And in fact, I'll refactor it. I'll comment this out and I'll do expect result to be 24. So that's a bit more readable. So expect compares that for us, and Jest will look at that and give us a different message depending on what happens with the test. This is called an assertion. We are asserting that when we pass 4 as an argument to our factorial function, the result is 24. We're asserting that factorial of 4 is 24. So I'm going to go ahead, do some copying and pasting real quick. What 24 times 5 is, I think, 120. Let's test factorial 5. I'm going to get rid of all of this. And I am going to leave this because the nice thing of this is it's just 1 line of code. And I'm just going to do these 2 tests right now, and let's see how we do. But you could go ahead and add more, In fact, let's go ahead and add, and this is the beauty, like once you have a nice pattern for code, especially for test code, copying and pasting your own code is totally okay. The golden rule is always understand what your code does. And we might as well test 3, and then we've got 1, 2, 3, 4, 5. And factorial of 3 should be 6. So let me ask you all a question. What if I make a mistake? And, the factorial of 3, 3 times 2 times 1 is 6. What if I make a mistake and I'm copying and pasting and I leave this? What if my test is wrong? Is that going to be easy to figure out? Yams, yes, sir.
Not quite, because it'll be like a false test.
It'll be a false positive. Yeah, exactly. So testing is super useful for a lot of things, but a test can never tell you if the test itself is right or if something that you didn't test is wrong. So testing has its limitations. So let's go ahead and run this code. The one and see what happens. Let me go ahead and just clean this up a bit. And let me actually demonstrate one more thing, which is just to organize stuff. We can use something called a describe block. Where I can stick all of my tests inside this other function, and it gives us a bit more comments as our tests get bigger. It becomes more and more useful. So I apologize that I'm jumping around a bit, and let me zoom out a bit just so we can kind of see the big picture here. So I've got this one describe block with all these tests. I just have one test within this other describe block right now. And so now what I can do is I can run this command npm test. Because this little change we made to package JSON, npm scripts are command line arguments we can give npm. And in the package JSON, we tell it what to do. And so I'm saying npm, when you get the test command, run Jest. And notice all of our descriptions in the describe blocks and the test blocks are here. We get these nice little green check marks when everything is good, if something went wrong. And it's actually always a good idea to make sure that your tests fail correctly. What if I had done expect true to be true? This is a contrived example, but it's easy to make a mistake where a test will always pass. So when you write tests, always do some double checking that they fail when they should. And here I've got a failure. It tells me what we expected, what we actually got, and it tells me where in the test file it is. And I'm using the undo keyboard shortcut right now with VS Code to do that, which is undo is Command Z and redo is Shift Command Z on a Mac. These will be Control Z and Shift Control Z on Windows. These are some of your best friend keyboard shortcuts right there. Let me run the test again to make sure I didn't introduce a typo by mistake. I should probably test 0. Can anyone remind me for a factorial, what is 0 factorial?
Should be 1.
Awesome, thank you. And let's see if we have that. And indeed, that's right. So that, in a nutshell, is testing. I think the one thing I want to show that is actually super useful, especially when debugging, is skipping tests. Maybe I have a problem in my code and I'm not getting 0. If in my test file, I stick just X in front of a describe block, it skips that whole suite of tests. And so this is why describe is really useful in organizing things. Or if I just want to skip a single test, I can just put X in front of that one test. And there has got to be a way to run just one single test out of the group as well. And I don't know that keyboard shortcut or that shortcut off the top of my head, to be honest. I'm sure it's there in the Jest docs. So the more and more you all get into the assignments, the more testing you will see. And we got to see some really nifty things. We're seeing arrow functions in action, higher order functions, first class functions. Again, we're going to be doing more Python over the next couple of weeks, but all of this stuff will be coming back. And all of these things are features of many different programming languages. Python also has first class functions and higher order functions, though they look and feel different and you don't use them as much. And other languages do as well. So starting to kind of understand these things that go beyond one specific technology or language that's the really valuable knowledge. And this is true of testing. All of this stuff is really common to testing frameworks in Python as well. And we're going to look at how to write Python tests tomorrow. And almost all the assessments you do will have a test suite where you want to get all the tests from red to green. There's a whole sort of flow to test-driven development called red-green refactor, where the idea is you even like write your tests before you start writing your code. And your tests are almost like your pseudocode or description of work. And you just work on adding one feature at a time to get one test passing at a time. And we'll talk more about that and demo that more as we get into the course. Right now, we're really just kind of introducing testing and getting used to having a test suite. And you'll find it's actually your friend because it helps you know when you're on the right path. And once you all start writing your own tests, it helps catch bugs. Because when you're changing or refactoring code that already works, it's so easy to introduce mistakes. Shockingly easy. And that's where a test suite can be incredibly, incredibly valuable. And so for the other assignments today, I would please do, like, even if you need to skip, we've got 2 blocks of assignments, the factorial, the Roman numerals, and the Fibonacci. I would say do factorial. And if you're not sure if you'll have enough time to do Roman numeral and Fibonacci, jump straight to Fibonacci so that you can interact with Jest and testing. Because we don't have tests for this one. And getting a little bit of time with Jest and using it for a problem is really important. Because all the Python stuff we will be doing over the next couple of weeks will have tests. So getting familiar with these JavaScript tests will help with that as well. And so here, as you can see, now all of a sudden, our programs are getting more complex because we're installing other libraries and we need to start using our package managers to do that. And there are scripts we run in order to do that. And the tooling and everything is starting to grow. So that's really the goal of a lot of this. And you can see, I would definitely recommend looking at this test suite, reading it, because this gives you information. Like from looking at this, you can tell I'm expected to write a function that takes 1 argument. So it's really valuable to kind of look at tests and spec files. So that's really it. I know we ran a bit long, so thank you folks very much. I do want to wrap up so that we can break for lunch, and I'm more than happy to stick around for a bit to answer a question that folks might have. So that's the plan for this afternoon, is working on these assignments. The breakout rooms will be open as before. Oh, the one thing I will say is, and let me pull up Slack to show this very quickly. And let me reshare my screen. feel more than free to work in groups if you want. Just make sure you're writing your own code to get that practice in. Please use the Whiskey Questions channel, and TAs will be watching, and Francisco and I will be watching. And that way, like if Francisco and I need to make announcements, we can do it here and it doesn't get too messy. And that way questions can go here so that we can track who would like a second set of eyes on something. And definitely follow the 20-minute rule. And that's really what it's for. Like, especially now in the early days, you shouldn't be spinning your wheels for more than 20 to 30 minutes. If you are, it's probably not productive learning. So definitely reach out. And of course, Francisco and I will be around on Slack, but please use Whiskey Questions so that we can just keep things organized. So yeah, thank you folks very much. Have a great lunch. Lunch will end at 1:30 Central, but then it's independent work time till stand down. And then at stand down, it would be great for someone to demo some code that they wrote today. And yes, what questions are on people's minds? I'm just sort of going down the grid list here. Landon, what's up?
Hey, how you doing? There's a question I just put in the Whiskey Questions. I think it's affecting more than just one person about your like initially set up for the npm init and getting errors back. I don't know if you could take a look at that. It might help a group of us over.
Yeah, totally. Let me take a look at that right now. Oh, yeah, this is a pseudo thing about like if you need to run this as a pseudo. They kind of hide it in there. They do actually tell you what the problem is and give you the solution. Let me just go ahead and share my screen real quick. Long story short, depending on if you use sudo to install npm and Node.js stuff as the root user or not, on Macs, you then always have to do it, or certain weirdnesses can develop. They kind of tell you what to do here. I would try this step that they recommend first, just running this command, which will use sudo to change the permission level for the directory in question.
I don't think you're sharing your screen anymore.
Oh, I'm so sorry. I'm not sharing my screen. And in fact, let me just go ahead and well, I'll keep the recording on and share the screen. So actually what's probably easier is let me actually just copy and paste this into a VS Code. One moment, folks. So here was the error message. It was buried in there, but they actually give you a suggestion of what to run. This command sudo chown. Long story short, it's going to change some file permissions. If you are seeing this, make sure you copy and paste this command from your own error message, because they also give you the path to your specific to your directory with your username and stuff. So try this first. If that doesn't work, just try running sudo in front of like the npm install command. Does that make sense?
Yes, I did that, and that resolved the issue. I think I was having the same issue as Landon.
Perfect. The running the command they suggested resolved the issue.
Yes.
Awesome. Yeah. Great call out. That is a confusing one for sure. And actually, let me go ahead and stop the recording.